Alright, time for underdraftphysics.com, debatephysics.com also. Same subject. Really, it is funny that, all of this conversation, years worth of arguments, can produce so little in terms of any progress or anything positive. Or again, even just the simple acknowledgement that all of this shouldn't even be a controversy because the evidence collected should be overwhelming because it's all so simple. It's as simple as just simple experiments where you drop 1 pound 1 foot and you drop 4 pounds. You drop 4 pounds 1 foot and 1 pound 4 feet. I mean, your car crashes. I mean, simple experiments. And some of them have been done. Again, the Mythbusters did crash cars, and nothing like 4 times the damage showed up, and everything like momentum showed up. So there is some evidence. There just isn't enough, and unfortunately. And there's enough confusion and enough bullshit out there that, it's still an argument, and it really shouldn't be. So anyway, Mindless Marbles keeps posting nonsense, and it just, just, I don't know what to say. I mean, it's just so belligerently off the subject and wrong. So he says something like, and Newton's third law to the list of things Newtonian mechanics draft science does not agree with, including Newton's second law. So again, I mean, how does the second law have anything to do with mv squared? Again, you could just argue, why wouldn't he have just said, it's this, mv squared? Why wouldn't he have just written it if that's what he thought the law meant, and that's what he thought the mechanism was, that the force is 9 times the force to go twice as fast, 3 times as fast, and 16 times the force to go 4 times as fast. Why would he say that? Why would he say exactly the opposite directly? I mean, and then to argue about the third law when you have the most obvious example is the gun. How is the third law being obeyed? 2,000 joules flies out one end, 2 joules goes out the other way. How is that Newton's third law? How is that anything like an equal and opposite reaction? And again, what would momentum mean if it isn't energy? If momentum isn't energy, then what meaning does it have? It doesn't mean anything. Why would anyone care whether momentum was even considered? Why would an MV be important if you thought energy was related to MV squared? Why would you even think about momentum? Because it's always lying to you. It's not telling you the truth. So what meaning would it have? It would have no meaning. They wouldn't even talk about momentum. It wouldn't be a thing. So of course it was a thing. So it's just such a denial of the truth of the period when this was argued. It's just such nonsense to pretend there wasn't a controversy, a disagreement, and that the disagreement was never resolved with anything called credible evidence. Impossible to understand. All right, so anyway, Mindless Marvels posted my comment on somebody, I don't know whose video it was, but anyway, I didn't go back looking at replies, so apparently there was a reply by this channel 123 guy who just keeps spouting the same stuff, so I eventually blocked him. But anyway, so apparently he did comment, and so he did answer some questions, so I figure, oh, okay, fair enough. And the answers are just plain stupid. I mean, it's it's just such a denial of all the arguments that have been made and all the evidence that there is, and all of the, I'll go through the pendulum thing again. I mean, so wait for that at the end of the video, because I don't know how you can rationally understand it working any other way. I mean, the mechanics are so simple, and there's really no way to explain it away. All right. Why are you evading the point about Newton saying the difference of those directed towards contrary ways are never changed? Because I don't disagree with it. What's Newton saying? He's saying, look, it doesn't matter which way arrows are going. It's just always the same difference. So if there's 60% and 40%, 60 momentums and 40 momentums, then what comes out is going to have that difference still in it. the same difference, 20, is going to exist somewhere. The difference in the momentums. You can't change how much momentum went in, but you sure clearly can't change the difference. So 100 goes in this way and 100 comes out the opposite way, right, in a reflection. The difference is always the same. So yes, so both of us can use that statement to our advantage, but there's nothing in that statement that says he is believing that there's a subtraction, that somehow two things come in with 50 and you have 0 momentum. He's not saying that. He's not saying there's any such thing as a cancellation. All right, why did he say that? Why did he even highlight it in a colliery? So it wasn't highlighted, it was in a colliery. So the thing that was highlighted was his statement that twice the force, twice the velocity, 3 times the force, 3 times the velocity. That's what he stated right under the second law. So I mean, as his description of the second law directly, the subtitle of the second law is twice the force, twice the momentum. 3 times the force, 3 times the momentum. All right, just answer the question. Fuck you. I don't know is a valid answer. So whatever this shit is. So that's the best you can do, is a counter argument to all the arguments I've made. Oh, okay. I'd say fuck you. That's just such garbage. All right, so obviously I don't agree that you can put 200 momentums into a collision and get 100 out. So that was part of my comment. Well, that was one of the results Newton got. So again, it isn't. So you can say it, but it isn't. So we're nowhere in Newton's description did he point out, look, we made free momentum in a direction. He never said that. So he never showed a comparison between, well, you hit the 1 mass into the 3 mass and you get 150. You get this extra free momentum out. So that wasn't in the description. So you're playing games with verbiage that was translated from Latin, and I'd say obviously the translation is imperfect anyway. Or Newton wasn't too good at writing, which he wasn't. Okay, he wasn't a brilliant explainer. He really wasn't. Okay. I hope you will answer my question below. I will try to answer yours. So these are whatever, questions and answers. So we'll see where it goes. So I said that 100 years of controversy regarding the living force is well documented. That's just a fact. It's well documented. PBS did movies essentially about it. There's just a ton of historical record. Now what's absent is any real argument over specific experiments. So it's really just an argument about, saying MV and saying I believe, and them saying NV squared and them saying I believe. So it's almost like a religious argument because there's so little evidence to be argued. Clearly the scientists of that time believed there was a direct contradiction between Newtonian mechanics and Leibnizian mechanics. And just I'm not going to argue it. So if you think you can make some kind of argument that the discussion wasn't real, that it wasn't passionate, it ruined relationships between people, that's the absolute fact. So fuck you, I'm not going to argue it. So he says, I don't think they believe there was a contradiction. It's just moronic. They spent a whole bunch of capital publishing, doing all this stuff, arguing in defense of, contriving thought experiments to defend. The French even had a contest, that they financed for somebody to come up with the right answer. And unfortunately, only like 4 people entered because nobody could do it. Nobody could produce a good rational proof. And that's just a fact. Unfortunately, I guess they just didn't have enough technology. But they actually did argue the lever, okay? So the fact is that people argued in defense of Newtonian mechanics by just pointing to a lever and saying your theory is makes the lever a free energy device. The counter argument was one hidden in pulleys, and the fact that, we can force 1 pound to equal 4 pounds if we move the 1 pound a lot slower. All right. Can you link to any evidence? So again, I'm not going to argue it. I mean, yeah, there's a ton of evidence. I've gone over it in videos hundreds of times. It would be just idiotic to have to argue the fact that there was a real this visa controversy. Just idiotic to argue that. I don't think you have read much about it, so it's just amazing. Just a few outline articles on Wikipedia. Liar. I've read the letters from Voltaire. I've read what you can get, okay, of de Charolais that's actually translated into English. So I've read her book, so to speak. All right. And if Newton was so much against mv squared, why didn't he say it later editions of Principia? Well, first off, he didn't see it as a controversy then, okay? And the second part of it is he had a whole different job later, okay? He was working for the Treasury. He had a whole different position. He wasn't in a position to argue this kind of crap. So his surrogates argued it. And they did a lot of it. They wrote letters and they argued it. This clearly was argued. Unfortunately, it's all veiled in a bunch of religious arguments, which really detracts from the scientific part. Obviously, Leibniz was really passionate about this whole religion thing, and he basically had called Newton and Descartes atheists and a threat to civil function. And so the Newtonians had to come to their defense. So 90% of the conversation was about a bunch of religious shit rather than about the physics. Or anywhere else, why did he say Huygens was right about colliding objects? Well, obviously 90% of colliding objects, everybody agrees. So, yeah, when they're going the same way, everybody agrees. When certain things are happening, everybody agrees. So that's why he said it. I don't think Newton took it very... There's only the one sentence by Huygens. Do you have anything else that you can show me that Huygens published demonstrating that Huygens believed in free energy, free momentum? Probably you can't. Okay, so that's the problem. So until you can show where Huygens said, yes, if you collide a 1 mass into a 3 mass, you'll gain 50% more momentum. Then you'll have an argument here. But that's not what Huygens wrote about. So the very fact that Huygens has one sentence where he says, I think mv squared is conserved, doesn't mean much. All right, if Newton had believed in let's understand, Huygens and Newton disagreed by a lot of things, and they did it very politely. All right, so Newton didn't have a problem with Huygens, and Huygens didn't have a problem with Newton in terms of them having any kind of animosity, okay? But Leibniz and Newton, yeah, a ton of animosity. All right. So whatever. So I don't think, he says, well, fuck you. I don't think you've done any research at all. You're just talking out of your fucking shitty head. That you deserve to be blocked because you do things like this. I don't think. Fuck you. You think based on no evidence. You haven't done any research, you liar. All right. I don't think they believe there was a contradiction. So bullshit. Can you link to any evidence? So again, that's the whole point. Leibniz's evidence was 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. The obvious assertion I'm making is that was an absolutely untrue axiom for which he had no proof. There is no experimental evidence where he proved that to be true. He just stated it to be true. I don't think you have read much about it, so fuck you again. It's just so amazing. Anyway, and if so much again, so why wouldn't he say so later? So I reread that part. Why did he say Huygens was right about colliding objects? So I already explained that. Because most of the most arguments about colliding objects aren't under controversy. If Newton had believed, that's the irony, right? Is that somehow momentum is perfectly conserved when two objects go in the same direction, and you don't see any problem with those, the huge failure, so to speak. So when you lose half the kinetic energy, you don't seem to have a problem with that. And that's the funny part. When you don't conserve it, you just make up crap and say, well, it made a bunch of heat or it did something else. You just make up crap. Like a half-mass bowling ball going twice the speed knocks down twice as many pins. You just make it up. You don't have any evidence for it. Let's see. If Newton had believed in mv squared, his first sentence under the second law would not have been, if any force generates a motion, double force will generate double the motion, triple the force, triple the motion. So obviously he wouldn't have said that if he believed in mv squared. And this idiot says, why not? Because the force is the thing that has that's the energy component of the statement. If force and momentum were identical things, okay, then there wouldn't be any conversation. Your whole point is that the force, the energy component, all right, and so clearly, unless you want to concede that force is also momentum, I don't know how you can do that, right? The force isn't in the form of mv. So you can't take the mass and the velocity of the force. Now, I could, my theory, but you can't. Okay, so you're stuck with what is force if it isn't energy? And why doesn't it, clearly it would have to have this extra component in it somewhere. You can't say that it doesn't take 9 times the energy to spin something 3 times as fast if spinning it 3 times as fast produces 9 times the force. So if it produces 9 times the force, then you have to concede 9 times the force had to go into it if you're going to believe in conservation. So too stupid a statement. Let's see, how is that statement different from conventional physics? Well, obviously conventional physics says it takes 9 times the force to spin it 3 times as fast, not 3 times the force. There is very subtle difference. Fuck you, it's a huge difference, but I doubt you understand it. No, there's no subtleties here at all. So, bullshit answer, right? This is just a waste of time, All right, do you think denting clay with round objects is a good scientific way to measure real energy? And so he says yes. So, hilarious. I mean, it's just funny, right? So, I mean, I've made the point that that's like saying it doesn't matter whether you have a point on your arrow. Of course, the point on the arrow is going to make the arrow penetrate further. So it creates an advantage in terms of how something penetrates another substance. And obviously, a circle, okay, a parabola, whatever you want to call it, is a shape. Okay, it's not a point, but it's still a shape. And it's a shape that has a flat bottom and has sloped sides. And it really matters what percentage, okay, of the flat bottom versus the sloped sides is in the clay. Will decide how much work you have to do, because it's less work to just push clay sideways than it is to push it down and sideways. All right, so I've already explained that 50 times at least. If the block of clay is large enough, so meaningless, in comparison to the dense, wide and thick enough, it doesn't matter that the object is round. So of course it always matters if you're just denting the clay. Now if you penetrate the clay past the halfway point of the circle, then it doesn't matter. But that's not how the experiment was done. Pushing clay is pretty much the same in any direction. So he's saying it's the same pushing clay down and sideways. That's what you have to do to get it out of your way. You can't push it down because there's no, it gets too compressed. So it has to go sideways. So the real trick is that all the clay ends up going sideways. The clay you press down and the clay you press sideways. Obviously, it's more work to push it down and sideways. So anyway, so bullshit answer. The fact is he doesn't understand physics. He's showing it right there that he doesn't understand that the shape does matter. Okay. Have you ever seen an experiment where 4 pounds dropped 1 foot in free fall produces the same impact force as 1 pound dropped 4 feet? So, and then he says, didn't Michael Falwell do something like that? Yeah, and I pointed out that he has a 3-inch spring, and he's only using 1 centimeter of it. So he's using like 10% of the spring. So it's a very fine measurement. You can understand you could measure something in this big scale where it's really obvious what's happening, or you could measure it at a little tiny scale. So he could have taken a shock absorber off a car, and then he could have measured 1/1,000,000th of an inch difference, you see, if he had a very precise measuring device. And which one do you think you should do? Do you think you should do the one where you need a microscope to see the answer, or do you think you should do the one where it's obvious? And then obviously he had a pointing device that had at least 1mm or 2 worth of error built into it. So you have a margin of error that's at least almost 50% of your measurement, right? So if you had a margin of error in a measurement that was 50%, what credibility does the experiment have? Oh, that's right, it has 0 credibility. And then we have the Dispar version of the experiment where he used a hammer kind of idea. So a swinging pendulum, and the idea was to have the 4 pounds, dropped 1 unit of distance, and the 1 pound dropped 4 units of distance. And what did he do? Well, he puts the 4 pound weight up here, so it doesn't fall the required distance. All right, so he cheats grotesquely, and he gets a result where, the heavy object still won. So in spite of this giant cheat, the 4 pounds did win, by a little margin. 18 to 20, some kind of, 10%. So it still won, and he hugely cheated. So what do you think if he did the experiment honestly? That is, if he did it fair and credibly, what do you think the outcome would have been, fuckhead? Oh, that's right. It would have proven the fact that, 4 pounds does have more momentum. Just a fact. So why don't you ask him to redo the experiment correctly? Yeah. Okay. Anyway, by the way, he has a great experiment proposal for you in his latest video, whatever that is. Go share your opinion, or maybe he'll do it. Fuck you. I don't have conversation with these lying pieces of crap. They put up videos with grotesque flaws in them, and then they leave the video up, and then they call me a deceiver, when clearly they're deceiving. Why would you leave videos with huge flaws in them and completely illogical declarations of a conclusion when it's garbage? Only a liar, a liar would be comfortable with doing that. So obviously Dispar, Ian Gosling, Stephen Bro, and Falwell don't give a shit about lying to people. All right, I've seen the lever perfectly oscillate, so I'll illustrate this one again. With one mass moving with 4 times the velocity and a 4 mass on the other side. How does your theory account for that equality? How do you explain the existence of an oscillator that has twice the energy going one way than the other? To explain this, I would have to explain what kinetic energy means. So again, what does that? What does that mean? Yes, that's exactly the argument. What the fuck does it mean? What is it? What it's magical energy. So what does it mean? It doesn't mean anything. It doesn't make any. It doesn't make any sense. What it means? It means you're saying there's special energy, and its special energy poofs away. So a ballistic pendulum loses 99.94% of the energy. And you just say something like heat, deformation, blah, blah, blah. But wait, you conserved 99% of the momentum. You can't make heat without using momentum. How do you make heat without using momentum? Just explain that to me. It's quite easy to explain to other people. What is this? No, I would love for you to explain it to a 10-year-old. Let me see you explain kinetic energy to a 10-year-old. I think I can explain it, as quanta. I can give them the quantum mechanical view of it and understand that energy comes in little chunks. And the little chunks are the protons, and the electrons are carrying the force. They collect it. But for some reason, it seems to be next to impossible to explain it to you. I wonder why. So what a cop-out. So he sits there and says, oh, somehow he's answered my questions. What a liar. I mean, what a pathetic pile of shit. All right, so and then Despar chimed in with some kind of crap. I'll share a link again where DS talks his way out of denying subtracting momenta. So again, all I can do is explain why I find it impossible to imagine the car crash where, okay, the elastic car crash, the two things crash and nothing happens because somehow it's magically canceled. No, it can't magically cancel. And what's going to pop out? What has to pop out is what went in. You can't have more pop out, and you can't have less pop out. So if you have a crash with 150 and 50, 100 can't pop out, okay? It has to be 200. All right, so let's do this. Get rid of this. And we'll do this one more time, just because over time we figured out some of this stuff. So I have explained this before, but maybe I can explain it even better. So here's your balance, and if you're hanging it from above, okay, the top of the balance, you don't have a fulcrum below, you have a fulcrum above. What will basically happen is when it oscillates, that is when you distort it, what you'll end up doing, okay, is changing how much mass is on one side than the other side. So as you tilt it up, all right, you add mass to this side, okay? This portion of the lever goes over to this side, all right? And so you can sort of understand this much mass ends up being on this side, extra mass, and so this side falls. So you don't need any weights on it, and it will oscillate. And the fact is if I put the weights on, it's sort of superfluous because the only mass I'm switching or changing is this. All the masses are just going to be equal. So they're going to just counteract each other. They're not going to mean anything. So I can hang the 4 masses here, and I can hang the 1 mass out here, 4 times the distance. Not twice the distance, not twice the velocity. Okay, 4 times the velocity to equal this. So this moves with 4x the velocity. Okay, it has 4 times the energy that this has. Okay, by mv squared. And so it's demonstrating perfectly that the only thing that's going to change, these two balance. So the whole thing is recognizing that to move this 1v, okay, to move the 1 little bit of velocity, I have to move the 4 units of velocity. And that's the truth of it, that it's the same amount of work to move this at 4 times the velocity as it is work to move the 4 objects at 1 unit of velocity. It's the same work. And like I said, the only energy I really did put in was I moved, okay, by tilting it, I moved mass from one side of the lever to the other side. Not these masses. These won't have anything to do with it. These changed absolutely nothing because they totally equal each other. So I could cut the lever in half, or I could take these off. It doesn't matter. As long as I have an equal amount of mass to start with on both sides, the only part of the lever that's going to have energy is this part. That's the only energy. I'm just going to switch this little hunk of mass from one side of the lever to the other side of the lever, to this side of the lever, to that side of the lever, and that's what's going to be oscillating. And so each time this little extra piece of mass, or I add this extra mass to this side, and so it's that little extra piece of mass that's going to be hit by the gravity, and it's going to force this to go in this direction. And when it does, it's going to overshoot, okay? And now there's going to be extra mass on this side. And it's always going to be the same amount of extra mass. So the same amount of extra mass collects gravity, moves this, okay, 1 velocity moves the 4 mass, 1 velocity, and the same mass, having gravity push on it, moves a 1 unit of mass at 4 velocity. Clearly, they're equal. Clearly. So, 4 pounds dropped 1 foot is not the same as 1 pound dropped 4 feet, because this is only twice the velocity. And obviously it's 4 times the velocity that equals. And again, if Despard redoes his badly done experiment, you'll see that this mass, this has twice the momentum that this does. The 1 pound dropped 4 units of distance has half the energy of the 4 pounds. And it's not, and this experiment proves it. If you want equality, you've got to make this go 4 times the velocity. I don't think there's any way you can explain yourself out of that. I mean, it's just so clear how it functions and why it functions, and what's actually oscillating. And the very fact is that 4 pounds moving 1 velocity is in fact the same energy as 1 pound moving 4 velocity. Same thing. Okay, same amount. Alright, so probably enough of a video, right? I guess I could do the mindless publish some other thing I haven't read yet. So, I don't know if I can get to his other posts from here. Probably not, so we'll save that for some other time. So anyway, till the next time and such and so forth, and fuck you. Fuck you. People are just so fucking stupid and obnoxious. Again, the very fact that they won't admit, gee, science really should have done these experiments. They won't admit that they've had 300 years to do these basic experiments, these basic bang something into something experiments, and they haven't done any of them. Disgraceful.